Now, the last thing we're going to be looking at in this section is the p-value method for testing a proportion. So again, just like the critical value method, the proportion and mean testing is very similar. The p-value, you still have to find your alpha level, you still have your null and alternative. How we get our p-value is going to be a little different. There's a different function to use on your calculator, but we're still going to let the calculator do that. Do the computations for us and use the function on the calculator. Okay? So we're still testing a proportion, and now we're using the p-value method. Your final conclusion is the same. If p-value is less than or equal to alpha level, we would reject the null. If p-value is greater than alpha, we would fail to reject the null. Okay, so that is the same as the first part of using the p-value method to test the mean. Okay. So let's get right into an example. A new seatbelt is produced that will lower fatalities in head-on collisions of 35 miles per hour or faster. It is known that 47% of head-on collisions of 35 miles per hour or faster result in a fatality when a seatbelt is worn. Data was collected from 200 random accident reports that had head-on collisions and the new seatbelt was used. 89 of the 200 resulted in fatality. Test the claim of the new seatbelt with alpha equal 0.01. Okay, so like before, the first thing you need to do is find your null and alternative. Okay, we are testing the claim that the new seatbelt will lower the current rate of 47%. So I have P is equal to 47 for our null. Our alternative, P is less than 47. The alpha was right in the problem. It told us alpha level of 0.01, so we're keeping that. And now we need to find our p-value. Now the p-value for a mean, we use the t-test on the calculator. This time we're going to use one prop z-test. Okay, so you're going to go to the same menu, but this time one prop z-test. Okay, so we're looking at the calculator. I'm going to go to stat. Go over to tests, and I'm going down to one prop z-test. So on my calculator, it's number 5, and let's look at the information you need to plug in. Okay, so that P0 is our null. So we had 47%. You do need to plug this in decimal form, so I'm plugging it as 0.47. The X and the N is our sample size and how many successes we had. Now, I know getting into a fatal accident doesn't sound like a success, but it's what we're looking at right now. So I have 89 of the 200 accidents were a fatality, and I'm going to highlight the less than symbol there. So now we have our null, our X and our N, and we have the correct symbol highlighted for less than. I'm going to go down to calculate. And there it gives us our test score. Again, it's a nice way of checking. Our test statistic is using this method. That's what the Z is. Our P is 0.2393536. And it does give us our P hat on our N. Be careful not to confuse the P and the P hat. Okay? The P is our P value here. So the 0.239 is what we're going to use as a P value. Okay, so here is all of our information, and the same judgment as before. If p-value is less than alpha, we reject the null. If p-value is greater than alpha, we fail to reject the null. So 0.239 for our p-value is greater than our alpha level of 0.01, so we're going to fail to reject. We fail to reject the null, so we side with the null. The new seatbelt has the same fatality rate as the old one. There is no evidence that it is any different than 47%. Okay. So we did not find evidence to say that it dropped to 47%, that the new seatbelt dropped it. So we're going to say that it's going to stay about the same as the 47%. Okay. So that was the example of p-value method, and that should be the end of this section and testing single sample claims.